On to our second speaker. He's from Tri-Systems Engineering, which is the Malaysia-based provider of industrial automation solutions. His name, Megat Shamsul Ariff, and he's a general manager at Tri-Systems. His presentation is all about universal automation, IEC-61499 application for offshore. So Megat, welcome to the stage. Thank you very much. Thank you.
Good morning. Just test the, okay. All right. So a bit introduction of myself. I'm with Tri-System for maybe about 20 years plus now. And early days, I've been doing offshore projects. So I've been to an offshore platform using helicopter, or using boats. And I can share, during that time, I've done a service job that took me 4 hours boat ride to do about 15 minutes of work and come back another 4 hours. So that's the technology at the time. That was the pain that many automation vendors face. And I think today, this is quite a unique case that I'm presenting. One project is currently on hold due to some changes in the customers. And then one project is we're having an FAT in our factory. So a bit of introduction. So on universal automation, so we are part of universal automation for I think 2-3 years now. And we've been in the business for, I think, about 30 years. So we started in 1995. And we've been doing oil and gas for quite some time. Then we diverted to power. We are doing a transportation project now for light rail transit. We were looking at marine, implementing some AI in marine. And also, we were looking at the new thing now, it's sustainable aviation fuel, or SAF, it's quite a unique product. So we are also part of IEC. I am Sharul here, IEC president. And so we are basically doing this system integration for quite some time. So the way I sell myself, I'm a system integrator from edge to enterprise, from how to get data and how to contextualize the data and how to put the data to work in let's say, in the AI platform. So we are started in Malaysia, then we expanded ourselves. We had a project in Laos, Thailand, Indonesia. So we can be considered as a regional player. So we like to do niche stuff. So that's where we feel that is sustainable in our business. We are going to the state-of-the-art technology. The reason why we joined universal automation is that we feel or we know it is something that the market will pick up, and I think it will something that will be the DCS of the future, control system of the future. So So about Universal Automation Organization. So our Universal Automation is an independent non-profit association. I think more than 109 members now. I met UAO last week. They said there's more people, more organizations joining. So it consists of system integrator, it consists of technology vendor, it consists of university, it consists of the end user. So major end user is part of this group as well. And we are promoting the shared source of runtime engine. So the runtime engine is something that that is can be once you are a member of the UAO, you can use the runtime engine in your hardware to implement projects on IEC-61499 standards. And it functions as a collaborative platform to deliver unified runtime for IEC-61499 based automation. So the association is like you have your Android phone, and you can put an Android OS on a Samsung or Sony or regardless of the hardware, but it's still an OS that is on Android. And this is something that coming from me. I think it's the modern modular standard intelligent distributed control and vendor agnostic industrial automation platform. Yeah. And it promotes interoperability, it fosters innovation and embracing Industry 4.0. I think this is something that I'm going to show in the next few slides. And the two speakers just now, I think there's few words that buzz me, like situational awareness, like efficiency, AI. So that's something that I'm experiencing right now. I did a predictive maintenance project, and yeah, this we'll see AI at work. So as a system integrator, we get technology from partners, and we build solution, and we deploy solution to our customer, and we maintain it. So this is a project that we did back in 2011, 2012. At the time, it was called integrated operation. There's another word for it that called like digital oil field, if that kind of word was in your mind. But we did this project for the enhanced oil recovery project. This is an aging offshore platform, probably about 30 years old or more than that. And we supplied a system, IEC-61499 system, and then right now it is going to on sunset. During that time, till 2011, 2012, till today, we supported our customer. We had a maintenance contract to ensure the system is maintained and operational. And then we were tasked by our customer to look at something for us to upgrade, to do something, a system that can be sustainable, future-proof, and so on. So that's where we come up with, we were looking at IEC-61499, and the proposed solution is to upgrade the components of the existing system and to rectify. It is located in hazardous area, so it's just an offshore platform. It's located in hazardous area, and it's certified by BV to be on this offshore platform. And we at the time when this project was given to us back in 2011, so the customer told me that I just will provide you 600 watt of power to power up the system. I provide you 2 Mbps of data, and it has to be located in the hazardous area. So it's a bit tough at the time that we were looking at how to do a control system with that kind of constraints. So, but we managed to do it. It's been running for now more than 10 years now. Then the hardware already, we got a letter from the manufacturer that it's already on sunset condition. And now we are looking at a new technology where it's much more power, using less power. It can be more data at the less bandwidth, and it is robust. So this is an offshore platform that we put the system. So it consists of a mother platform and 7 well-hit platforms. And it's communicated with the digital modular radio. At the time was 2 at the start, then they upgraded maybe about in 2015, 2016 to 10. Now with the new, you call it 4G LTE, or right now they are looking at 5G. So the speed of the wireless system is increasing. I think about 100 Mbps now. So this is the system that we delivered back in 2011. So we had a PLC system, PAC 8000, and then we had a Kingfisher RTU system for the data buffering, and we had I/O integrated I/O with IS system. And to do this upgrade, so we were looking at some components with our partner. So we are upgrading to IEC-61499 automation system with a Modicon M580 DPAC. And the I/O, we were looking at a back-off I/Os integrated with IS. And there's a unit there, and we call it a Kingfisher RTU unit that we going to replace it with Moxar small box, a small computer, which is quite powerful enough to do this kind of task. So this is architecture that we developed. So we on IEC-61499 platform. So we have redundant M580 DPAC for reliability of the systems, and it's connected to a set of back-off I/Os system, and we have a Moxar unit for the edge data store, data buffering, and to do some unique thing that we are going to have more edge processing. We have data, we process it at the edge before we send out to the mother platform. So there's a standard that we refer to. It's the IOGP report 627, 2018. So this standard, I mean, you can download it. You click IOGP and you get this report in. So there's one case that we refer to for this automation system. From the central control room, is the mother platform, and at the left, the remote location is the offshore well-hit platform. So we have the communication link, and safety is something that we need to separate right now until one fine day. IEC-61499 will have a safety system based on IEC-61499, but safety is still 61131 system. So we have our communication line. We have our edge computer for on-site data processing, and HMI actually for an offshore platform is not required. We do put in HMI for this wellhead platform is for maintenance purpose. If let's say people come to the offshore platform, they will turn on the HMI. Once it wants to demob from that platform, they just turn off. So because of power, this platform is powered by solar panel or wind turbine, so they have a constraint in power. So we need to make sure the system that we put in is a low-powered systems. And what we have to do here is that we need to create a system that can have on-site processing power, to conserve the bandwidth and also the power. So this is the architecture for the system that we had developed back in 2011, 2012. So we have from the offshore platform there at the right side of the screen. So that's connected to sensors, connected to actuators, connected to monitor like the charge controller for the solar panels. So it connects to a PLC system that we deployed, and then we had a digital modular radio to send in the connection to the mother platform, and then it connects to the currently it connects to the DCS or the normal DCS systems. But in here, what we are going to do with the upgrade is we change it to 61499 compliance PLC systems. Still connect to the same DMR, probably now with a better bandwidth, about 100 Mbps, I was told, and connected to IEC-61499 EWS. I think the last presenter kind of like, remember the golden architecture, so it's the same thing, your PCN, the DCN, and goes to the EWS at the mother platform. So this is the overall architecture of the system, 7 locations, and connected with the DMR, and at the mother platform, it's previously it has connected to the DCS systems. Now we are embracing. I mean, we were talking about OPC UA as the backbone of the communication, right? So we are using OPC UA, and then the OPC UA also connected to the Pi historian system. And this is where, from the Pi historian system, it goes to an application software to enhance the oil recovery by using some unique technology from the vendor. So we take data from the offshore platform, and it goes to this network and goes to an historian system. The historian will feed that information to an application whereby it will know the oil position on the seabed. So the system would able to intelligently inject the gas from the mother platform. So they inject the gas and to recover the oil from this aging field. So I've used an Aviva system for this proposal. We put in the Aviva Edge Data Store for the data buffering and local, data processing. It will run on Linux 11.11, and it has an API that we can do some unique things. We can put a Python code on it and to do a kind of like AI program on it. And you see here, the reason why I put this slide is that the edge computer just consume about 4.5 watts of power. So the whole system that we deployed is, I think, less than 500 watts for the small offshore wellhead platform. And this is something I think it was touched by the two previous speakers just now. So with the system that we have proposed, or we are actually the customer already have the agreement to proceed. It's just that there are some changes in that management of the offshore field. So from the IOs, it goes, as I mentioned, to the system, and we are going to put in model predictive control at the edge using Linux Debian 11 OS. And this MPC engine will have MIMO, multiple input and multiple output, that can provide the set point for the gas injection process. And it will directly integrate with the PNID control in the PLC. So what it provides is that now I don't need a big bandwidth now because of the difference with this 1131 and IEC-61499. 1131 is a scan time base, so it has to go for a scan time base. But 61499 is an event base. So in terms of bandwidth, it is a much more less, you can consume less bandwidth on it. And the PNID will be more optimized, and there are a lot of processing that we can do on site. And now we can have a better, less power to power up the systems. And we are looking at reducing the communication, reducing the energy consumption. And there's a word that I'm being tasked or being asked by customer is the word autonomous. So now, instead of you send the data all the way from the wellhead platform to the centralized server somewhere probably in that mother platform or in onshore, you do the processing on the edge. So that is what I define as an autonomous operation. So this is another project. This is the one that we're having in our staging area now. It's for barge, for power management systems. So it is the barge is used to pick up then an offshore platform from the yard and go to the location where the platform needs to be located. So this is the barge. They have the engine control room, the shore supply, the engineer room, wheelhouse, and they call it the emergency diesel generator. This is a single line diagram of the barge power systems. And then we convert it to the proposal architecture. So it is about 720 plus IOs altogether. So the vision is they had decentralized system. They had a manual operation of the power management system, and they want to have this central monitoring system to do this power management system. Previously, they are using walkie-talkie. When they start up the big crane, they use human to start and stop the engine. So we come up with an IEC-61499 architecture connected with all these 6 gensets with the IOs and also the switchboard, and also provided that data to the HMI that goes to the captain, the chief engineer, the wheelhouse, and also the switch gear room. So there's a unique thing that we had a problem, or we had an issue to get data from the gauge. And it's something that we had a problem with, and some solutions that was considered. So this is one of the solutions that we considered is using Vision AI to take the data and use it in the control systems. So We have our normal I/O systems. We had normal DI, DO, AI, AO, and we were looking at to put a camera to take the data. So the camera would have a computer, a Linux computer, to have the AI, the vision AI, to run and interpret that data and push it to the control system to do the process, to do the monitoring, and to historize that data as well. So yeah, we are using OPC UA for that, and yeah, any question we'll take up after this. Yeah, thank you.